What if your mindfulness practice was protective against things like Alzheimer's and dementia? Hi, my name is Teb Meissner, and welcome to Mindfulness Voyage. And today we're going to be looking at research around how focused attention practice may be protective against those very things. Let's get started.
Our guest today, returning to at least one of my podcasts, is Dave Vago. Dave, thank you so much for being here. Good to see you again.
Oh, great to be here, Ted. I love how informed your audience is about what's happening in the science of mindfulness and meditation, and just trying to keep everybody informed. So, got exciting stuff happening here.
Yeah, very exciting. When I saw the new research that we're going to talk about today, this is one of the things that stood out to me very particularly. But I want us to give a little bit of a background about what some of the puzzle pieces are with this, because there are a lot of moving parts with this new research. So maybe you can say a little bit about what some of those pieces are, like what is focused attention, what's
Mhm.
cerebrospinal fluid, and any other puzzle pieces that might be important for our conversation.
Yeah, no, it's true. Let me back up even further than that. I thought I'd start with just meditation and aging, and why we know meditation may be good for aging. One of the things that we started with doing research was looking specifically at the changes in the brain that happen in meditators over time, cross-sectionally, so across styles and across traditions. Is there an effect on the brain of these meditators, and is it changing across time and age? And the thing that we find in most of the meta-analyses of meditators, long-term meditators, is that even when you have just a little, practice on a regular basis, as you get older, your brain seems to be protected from the age-related atrophy that everyone else has. So that was interesting. That happened. That's something new. That happened in 2005. There was a paper that came out with Sarah Lazar. Lots of people were on that paper and looked at the frontal polar cortex, which is right behind the head. It looked at the insula, which is a really important area for interoception or body awareness. And this together, these brain regions were really starting to show activation, gray matter changes, and be highly involved during the meditation state. So there's something about that network that seems to be important, and that was figured out, maybe 15 years ago, and that it was not degrading in the way that most brains were degrading over time. So there was some hints that meditation was doing something for helping protect individuals from some of the age-related decline that you see in the brain. And that was an important clue to what we started to look at. And after, you can find a number of publications out there that look at this. Giuseppe Pagnoni has done so. Eileen Luders has also looked at the effect of meditation on age, and you can maybe list those in the liner notes of the podcast, Ted. I think that might be helpful. But then we did a systematic review of all the MBIs. What do mindfulness-based interventions, the 8-week interventions, how do they help protect cognitive functioning, or do they improve cognitive functioning? And so we did a huge meta-analysis. It was a huge team of people from all over the world. I mean, there was everyone from Natalie Marchand to Antoine Lutz and his group, who have been very interested in looking at how meditation protects age-related decline in people who are over 65. And what we found was that cognitive function wasn't actually getting better in meditators who typically go through these 8-week programs if they didn't have a deficit already. And what we found is that if you're over 65, you are likely to have some sort of cognitive deficit. And if you're meditating, you're more likely not to have those deficits. And so that was where our meta-analysis was really pointing, that anyone over 65 showed sort of a cognitive reserve, that they were protected from any of the decline. So there's another hint that something's going on with meditation that's protecting the brains from degrading in some way. And that was one of the motivation that we had for the study that we did at Vanderbilt more recently, was let's look at a system that protects the brain, a system called the lymphatic system. And there's also an important part of this lymphatic system that I should mention before I get into the details of it, is that we know that when we sleep, that there is a lot of restorative effects of sleep. We don't know exactly how everything is restored, but about 10 years ago, actually it was around 2012, when Maiken Nedergaard, who she's a Danish molecular biologist, she used 2-photon imaging. There's a way to image what happens when you track a tracer injected into the cerebrospinal fluid of the brain, and wanted to know what happens when you do that, and is there any sort of change in how some sort of metabolite or some sort of piece of debris may be transported differently during the nighttime versus the daytime. And what she found was this dramatic increase in just shuttling of this dye that was injected through the perivascular pathways. And what those are basically, in every brain, you'll have these a vascular system, a very vast vascular system, and you can look at how that there's going to be these pathways that open up during sleep. They open up about 60% of more space is created between the glial cells that are being used to create a channel around every artery that's in the brain. It's quite impressive that it does this. And when it does this, it starts to use those portals, basically those channels, for sending all the neurofluids through the brain to cleanse, essentially, of all the debris, and to provide any nutrients necessary to the brain parenchyma that are required. So you have this automatic kind of, I call it the good kind of brainwashing, and it happens during sleep. And so now we know, because of this discovery of this system, this called the lymphatic system, is that it's really critical that it turns on at nighttime. And if it doesn't turn on at nighttime, things will start to accumulate. And we know that in an aging population, where we have about I think it was in 10% of the global population today is about 770 million people are over 65 years old. And by 2050, that number is expected to rise to 1.6 billion. So we know that we're getting older, we're staying older, and it's going to be an issue for people who age, because not only do they have age-related decline, but they have sleep problems. So, when you look at people with sleep problems, they don't turn on that lymphatic system. And it's the combination of problems. So it was about 70% of older adults over 60 have a sleep disorder, mostly obstructive sleep apnea. But what Maiken Nedergaard really found from her research was that there's a clear increased risk of cognitive decline and dementia with those individuals who have chronic sleep disturbances. So the more we age, and the more likely that there's a sleep disorder, there's more likely to be dementia or some kind of neurodegenerative disease, whether it's Parkinson's, Alzheimer's, even Huntington's. It's going to increase the progression of the disease state. And that was fascinating, that kind of relationship, and realizing that there was a very clear relationship between the lymphatic system and sleep. and dementia itself. So that then there became an interest in how can we measure this lymphatic system better. And Mike Nendergaard at the university, she went to the University of Rochester, and she started developing ways of measuring these neurofluids and their movement in the brain. And when we talk about neurofluids, yes, cerebrospinal fluid is probably the one you've heard of most. That's only about 10% of the fluid that's in your brain. You have about 70% of your fluid is intracellular fluid. So the fluid that's inside all the cells. You have, 90, 68 or 100, almost 8, maybe 90 billion cells. Okay. So those 90 billion cells, most of those cells are filled with fluid. And then between the cells, you have what's called interstitial fluid. And then there's a organ that was also discovered more recently called the interstitium, which connects basically creates an intracellular matrix between the cells, and that interstitial fluid goes between that matrix. It's like a spider web of connective tissue that kind of keeps the cells in place. It has the chambers where fluid can move through it. So now you have CSF, intracellular fluid inside the cells, interstitial fluid, which is all around all the cells, and you do have blood, which is also a liquid, which is only about 10% that's considered still part of neurofluid. And then you can look at flow rates, and then things started getting really interesting because we now know that there's really three parts to the lymphatic system. One is that you see this influx of cerebrospinal fluid coming from the choroid plexus, as a part of the brain stem that actually produces CSF and produces a whole lot of it. I'm not exactly sure how much, but it's a lot every day. And it has a purpose to not only clear out metabolic waste, but to protect the brain from impact. So that was part one, is this this influx of CSF. And then there's another part, which is the exchange of the CSF fluid with interstitial fluid. So in the intracellular matrix, you're now having an exchange with CSF. And then you have an efflux of all of that fluid that was measured coming out of the venous system through the sinus cavities and then into the lymphatic system. So now we've found this great network of channels that is really responsible for mobilizing not only metabolic energy, nutrients, removing waste, but also immune signaling. And so it's really important for mobilizing immune signaling across the brain and the body. So we have the lymphatic system in the brain and the lymphatic system in the body. And so that's where we started. And then the question was, okay, if all these fluids are moving a lot during sleep, what role could meditation have in influencing this system? Perhaps it's going to be helping with age-related decline. And so that was the original question that we had, and we decided to look at mindfulness. And by doing so, we had to pick a type of meditation that we would start with. And for a number of reasons, we chose one in particular called focus attention. And focus attention meditation has a very unique profile. It's meant specifically to stabilize your attention on an object. And in most cases, especially in the Vipassana case, it's the breath. And the breath, we also thought would be very helpful, because we know that breath also varies during the nighttime. And there is some sort of relationship with the breathing cycle and how CSF fluid moves back and forth through the brain and through these channels. So we chose the focused attention mindfulness-based practice, where people had to just focus on the upper lip. We chose the upper lip so everyone was being consistent. and that was a concentration practice, and we wanted them to have some expertise. So they had at least, I think it was over 2,000 lifetime hours, which doesn't sound like a lot, but if you think about what that breaks down to, it's like 10 years of practice, 4 hours a week of meditation. So it's not insignificant. It means that you're really meditating a lot. And we needed to show this in experts first before we could start to say that it can happen in a novice. So we found people who were expert at doing this. They had the expertise of doing focused attention meditation. And we also noticed that when you meditate, your breathing rate changes without you even probably knowing. But you typically slow your breathing down between maybe 14 breaths per minute to about 10 breaths per minute while you're meditating. So about 3 or 4 breaths per minute drop. And a lot of people are interested to know, is that drop in breathing rate responsible for maybe some of the brain-related benefits that we see? And we're looking into that, and that's a really important question. And if it's the attention component of meditation, then we have to really control for the respiration. And that means you either take it out of your statistics processing, or you put in an arm in your study that just has paced regular breathing that matches the meditators. And so that's what we did. And we looked at novices who have never meditated, but reduced their breathing rate to the same rate as what the meditators were doing at the same time. And what we found was that indeed, that even at the baseline, so they were doing nothing, meditators were just doing nothing, and we were looking at their cerebrospinal fluid and the movement of that CSF movement. And we found that even at baseline, they were significantly less than the controls who didn't have any meditation background at all. So that already said something. It said that there is something about their glymphatic system overall that may be more efficient, that its flow rates are different for the meditators versus the people who were non-meditators. And this is where it gets a little interesting. You would think that the more movement, the better, the health benefit. But it turns out that if you have large spaces in your brain due to atrophy, you'll see a lot more sloshing around of the fluid. And so you can actually compare how the efficiency of how this fluid moves. And meditators were showing that they were just moving slower. The rate of flow was actually significantly slower during one of the cardiac phases of the heart beating. And when the heart beats, a lot of fluid is sort of pulsing. And you can look at the rate of that pulsing. And we found that there was a significant reduction in the rate during what we call the regurgitant flow back through the brain after the heart has beat. So that was the first thing that we saw. And then when we started to look at meditators who were at rest, doing something completely passive, which is what everyone's very good at, mind wandering, where they're not meditating, but just sitting there, letting their mind go freely to whatever thoughts and feelings that they're experiencing. And we found that in comparison to the mind wandering state, that there was also a significant decrease in absolute CSF movement that was happening. And again, we looked at what may be causing that. And there were some just differences in how the speed in which the CSF flow was moving during the systole time frame of the heartbeat. So the heartbeat has a systole and a diastole component of the heartbeat, and that during one part of the CSF or of the heart beating, the velocity or the speed at which the fluid was moving was significantly less. So suggesting that there's just more consistent and efficient regulation of that fluid movement while you were meditating. So that was observation number 2. The third one I think is even more interesting, is that you typically see this movement of fluid in a rhythmic kind of pattern through parts of the ventricle or the choroid plexus area where it's being produced. But you can look in the spinal column or the fourth ventricle and different spaces within the brain, and you see that there is a frequency by which these fluids are moving. And there was a paper that came out in Science and showed that there was this rhythmicity, about 0.05 to 0.08 hertz during sleep, that represented this glymphatic system. So it's rhythmic. And we looked at the rhythm during a mindfulness practice, during the focused attention meditation. We found that the rhythm matched the same rhythm as what was found during sleep. So that's very interesting that it has very similar kinds of effects as sleep does to this system. And there's evidence now that people are using entrainment methods, things like tones, music, or direct brain stimulation at that rate that seems to be very sensitive to activation of the glymphatic system in that rhythmic form. And this is where it gets interesting. I think even more interesting, Ted. There's the frequency that it's very most sensitive to is gamma, 40 hertz. So you can take essentially the rhythmic nature of that glymphatic system is responsive to a 40 hertz cycle, and 40 hertz is not typically what we see in meditators who are doing a focused attention task. We typically see 40 hertz in a non-dual, maybe non-referential compassion meditation. That's more typical for that style of practice. But that's the frequency that this system seems to be most sensitive to, aside from just doing the focused attention meditation. If you were to induce some kind of flickering light and sound at 40 hertz, you could entrain the brain to fire at that rate, and that would also entrain the glymphatic system to become engaged and start removing metabolic waste as well. And so now there's in published in Cell, in Science, a group from MIT have started startup companies that have developed goggles to help stimulate the glymphatic system in age-related decline population, and they're finding that it's starting to actually have some benefits for people. So all of that to say is that we've now published it in Proceedings in National Academy of Sciences. We're very excited about that. And usually, when it's published in that kind of high impact journal, it means that it's a very high impact finding. We now know everyone's going to be looking for using that kind of outcome. Does the glymphatic system, is it active or not? For different types of therapeutic interventions. So that's one of the things that people are going to start doing. Like, does psychedelics work? Does open monitoring work? Does different styles of practice? How about just breath work? There's a lot of questions, but they all seem to be good for benefiting the slowing down of age-related decline.
There's so much there, and I really appreciate, Dave, you sharing your insights, your knowledge about all of these moving parts and how they all connect, because it's rarely if you do meditation that directly causes the following outcomes. There are these cascading effects and so many different pieces to it. So I want to just say thank you so much for lending your understanding and your knowledge about all of this stuff. And for those who are doing a focused attention practice, that's one of my primary practices, that's not lost. When you're talking about the 40 hertz, like that's my recollection is that was not a focused attention practice range. That was more around what you were saying with compassion-based practices as an example. And here's another one of those, I think, wonderful complexities is that focused attention practices help us keep on our compassion practice or whatever it is without, again, getting caught up in mind wandering. So that's not lost effort in any of that. And what I really liked about this is that throughout our conversation, you're saying, here's the really interesting part, but then this interesting part, everything so far.
I know. I get
Absolutely
so excited about
with
it.
that. Yeah.
It's been 3-4 years since or maybe four or 5 years since we conceived the project, and you get so excited when you get to the end, and that's where we're at now. And I'm just like, I just it's one of the best studies that I ever did, and I'm just excited about it. So it comes through when I talk about it.
It does. It does. And that's actually why I want to wrap up, respecting you've got some other things you need to get to today. Is just one last question on this.
Yeah.
Is with all the interesting things that have come up with this, what are some things that you would like to see that maybe haven't been done yet, or just on the chalkboard as things we're eventually going to get to?
Yeah. I think if we could do in real time, start to look at how we can optimize the flow rates and the different activations of the neurofluids. What is it that's going to maximize those types of changes? So it could be for some people that so even just like a regular box breathing or some sort of ratio breathing protocol is going to work better for doing that. Now, the crazy thing that we see and that most people see is that when you hear about meditation, you hear a lot about how it could maybe benefit sleep, right? But it's a complex question, because meditation helps with sleep related and sleep onset insomnia. It's like people, when they can't sleep, they're usually in their heads talking to themselves, ruminating about the day, thinking about what happened, maybe thinking about what they're going to do tomorrow. And that for those people, a body scan or some sort of light breath meditation may be very helpful. But the more you sleep, the more you meditate, you start to see something change. You start to realize that you're not going to sleep very well. When you're on a meditation retreat, you don't often sleep very long or very deeply. Your sleep inefficiency actually goes up when you're on a meditation retreat. So those people who meditate a lot are actually getting the restorative benefits of sleeping while they're meditating. So they don't need to sleep as much. And so that kind of relationship as to how much sleep you really need, and during retreat, would be great to know where the balance is there by measuring the glymphatic activity during a retreat setting. And then the different styles of practice would be good to know if there's any specific styles that it's much more sensitive to. We want to know, of course, if maybe certain yoga classes or certain postures that are going to also benefit doing or activating this lymphatic system. And then lastly, probably the psychedelics, to see if they're having such a dramatic effect on mood. Can they have an effect on lymphatics as well? I would imagine they're not going to have the same kind of changes, but the fact that there's so much metabolic waste that's also involved in being recirculating, that it's mostly going to be for helping people who are aging. and helping with longevity or really just living well into old age.
Yeah. Well, for those who are watching, I will be putting some links where links are found on whatever platform you're using for this. And again, many thanks to our guest today, Dave Vago. Dave, thanks so much for being here.
Yeah, thanks, Ted. Thanks for bringing me on. I'm glad. Hopefully, if anybody has questions, they can reach out to me or Manus Donahue, who's also the principal investigator of the study, and he's at Vanderbilt University Medical Center. And you can find me at probably just contemplativeneurosciences.com.
Thanks so much for watching, everyone. I hope you enjoyed this episode, and please do remember to tap that subscribe button. It really helps. And remember, every moment you have a choice. Make it the best you can, and I'll see you again soon on Mindfulness Voyage.